Hey people, I'm in Alex and I want to make a short, oh no, it's probably not gonna be short, but yeah, a tutorial on doing a CodeCave hook. So, to start with some explanation, well, we're gonna hook open process. And we're gonna hook this process as a demonstration. It's just some random crap I found in Google. So, by hooking open process, we will make it return nothing whenever it wants a handle to a process which it need to terminate a process. So first of all, we'll need the APIs that we're gonna use, or Windows functions. So we'll need open process, which gives us a handle to the process that we want to hook. Yeah, that's what you're gonna do when we are making remote procedure calling, how Windows works. And close handle is a function we will need to close the handle again when we don't need it anymore. That's just a good practice to do so, but we wouldn't actually need it. Get proc address is to retrieve the address of the exported function in the remote process that we want to hook. Write process memory is to write to the memory of the remote process, and yeah, what we're gonna write is of course our hook code into the CodeCave, and to override the original function that we're gonna hook with a jump or call to our to our CodeCave by placing an offset that it calls. So jump to virtual log x is actually to make a CodeCave. It allocs some memory that we can write to in the remote process. Virtual protect x is to make sure when we write to the original function that we have the right access rights by applying the access right to the memory region that we want to write to. So let's start out. Oh no, let's just make, let's call it a start out. I'm just gonna make a function called get model base address, and we will need the process name in this, and also a variable with the model name. Whoops. This function is, this is not a function. Is going to retrieve us the address of the base address of the module which contains the exported function that we want to hook. Normally I would use the create help 32 snapshot Windows function, but yeah, this is much simpler actually, and probably the best way to go around it in .NET. I know many users create tool help snapshot because they think they don't need a handle when doing it, but they do. So yeah, this way is actually just as good. Whoopsie. Yeah. And for each then if p.model name equals model name, then I'm just gonna do like this. So we're sure they're both in the same, they have the same capitalization. If this one, if they're different, we don't know if there should be a difference, but just to make sure. So no, there we go. Then return p model base address, probably, yeah. So now this function is ready. quite simple. We can just, no, we don't want to test it out yet. Fuck that. Ah, yeah, we will. It's always good practice to just see if it works. Console right, like get model base address, and the process name is PSC killer 3, and this is the model which contains exported function we want to hook. So this. Let's see. Yeah. It works. Yeah, looks good. So now we go on to our hook function. Oh, subroutine. Subhook. First we'll need the hook code, of course, pass onto this. Oh, sorry, I'm a little sick. And then we will need the process name and the model with the export, like this. And the function that we want to hook. Function to hook a string. So now that's done. Okay, so let's declare some start stuff. Well, we'll need the process handle, obvious, and we'll need open process to get this. Sorry. And first we have to set the access rights we want to the process, which is these constants. No. Oh yes. Yeah. This will give us VM operation, VM read, and VM write access. So we can operate in the process space of it, and we can write to it, and we can read from it. So yeah, that's perfect. This is false. We don't need to give the handle to something else. And then we need the process ID. Get processes by name, process name, and I think it's What did I do wrong here? Oh. And then we will need the address to a CodeCave, which is where a new function is gonna be. Let's just call it CodeCave address. Probably a better name. CodeCave address as integer. This is for 32-bit, so yeah. Just need an integer. Here we use the process handle. Here we set null or 0, because we don't have any reason to make an offset to where we want the allocated space around to be. I think that's what you use that thingy for. And allocation type, I think it's you can just if you don't know what this means, these means, then just search the API up on MSDN. I don't want to waste time showing you it, because will make the tutorial take a lot longer. So yeah, what's wrong? It's gonna be, yeah, tuned. And this too. What? Oh yeah, that's right. And then we need the target address, which is the address to the function that we want to hook. And we're gonna use getProcAddress to get this. And the process handle? No. Where is the function? Why do I call this? Let's call it model handle. I mean, it's not. Oh, just call model address. So, and now we use the get model base address this function. Process name and the model will export. And the name of the function that we want to hook. Forgot, we already have it there. And this should retrieve, yeah, the function, yeah, the address of the function you want to hook by using getProcAddress, and yeah, a little function up there. What next? Then we need the offset. We just need to declare. We don't need it yet, because first we'll write a hook to the CodeCave or hook code. So let's use write process memory, and the base address to a CodeCave is, yeah, the CodeCave address. The buffer of what we want to write to it is a hook code. The size of it is obvious hook code.length, and it needs to be a integer. I think you could just make this be integer, but it's actually right to make it a integer, because in C++ this is called dword, which is a integer. And nothing, we don't need that shit. Oh, this needs to be a pointer. And now we're gonna calculate the offset to a CodeCave address from the original function. And we're gonna do it like this. If function address of a CodeCave address is smaller than the target address of the function's hook, then the calculation would be like this. And then we need 8 of these. Is there 8? Yeah, there's 8. Minus target address minus the function to hook, and minus 4. What did I do wrong here? Oh, I totally forgot. A CodeCave address, obvious. Well, this is -1 in hex. I think this looks better than doing -1, because this is an offset, and addresses is normally made as hex or written as hex, and -4. So this is actually, we calculate the offset and by this, and minus it with 4, or we can say 5, because this is -1. They could just as well have been 0, but it's -1, so we minus it with 5 bytes, because the original function is 5 bytes large. So if the CodeCave address is not smaller than the target address, the calculation would look like this. CodeCave CodeCave address minus target address. Because here we don't need to go backwards when jumping to with the offset. Here we go forward, so yep, the offset will not have to be flipped. Yeah, a flipped address is how I would call it. So now we just need the last part when we want to replace the original function and place the jump or call. We're going to use a jump in this tutorial to a CodeCave address. So we make an array, merged array, because we're going to merge two things into it. So byte, and then here. So first we'll get, whoopsie, the size of, I'm messing up right now. The size of E8, which is jump as a hex. No, oh my god, that's a call. Yeah, this is a jump, which is, yeah, the jump in hex, and we need its length to get the size of it, obvious, and then we plus it with the size of our offset. There we go. So now that's ready. I think. Yeah. And whoops. Then we need, I think I'm missing something. Yeah, we have to minus this to 1 because it's an array. Yeah. And then we have to copy the jump into a merged array. So get bytes. Oh, we don't need to do it like that. Why is, okay. Just have to type some more. And we copy it to our array at start offset 0. And now we need to copy our offset to the array. So we just take this and do it like that. And we put it at start offset 1 because we don't want to overwrite this. And now we declare a variable which is gonna contain the old protection, the old protection access, or the access right to the memory space that we are writing to. So now we need to unprotect where we want to write a stuff to. Did I do something wrong? Yeah, I did. And the address, which is the target address. I just have to make this a pointer. Ah, yeah, that was your training. No. Then I just have to type it manually. Oh, they can be smart there and skip it. Okay. Then we need the size of our merged array. As integer. And the nil protection constant to be applied to the memory space. And the old one we want to save. Yep. So now we can write to it with guarantee. So let's write to it. The base address would be like before. Target address. And what you want to write is the merged array. And we have to say how big a size of it is. And we don't want to know how many bytes we have written. We already know that, so fuck that. And then we want to reprotect it again. Oh, and we put the old project here, and now it's reprotected. So now it should actually work. Oh, we're just gonna clean up after ourselves. Close process handle. Oopsie. Process handle. Nothing. This is you don't need to have to do this, but that's just an old habit of mine. Whoops. Oh, then I deleted it. Okay, that was irritating. And then we want to just write some stuff, so we can need to examine what we have done. Just to see if everything works perfectly. Why is it so small? We have it. And the offset. I'm just gonna put this in hex. And then make a no, we don't need that. Should probably just do this. It's very important we always make sure we handle the errors correctly. Okay, now this should be ready, but I'm actually not sure if it's gonna work, cause I haven't tested any of it. So bear with me if this doesn't work. I'm just gonna fix it up. Some of you might actually probably already see some stuff that I did wrong. So a hook code would be some code which actually just make it return nothing. Yeah, there's not more to explain this, because if you don't know how ASM works, well, bad luck. Go and read about it. It's your best option. This is a very simple piece of hook code. Hook. Yeah, very simple, but this is, like I said, just a tutorial. You can use this for many purposes. The most optimal way to go about hooking the Open Process API would probably be to grab the process ID, do a check in your hook code, and make it go back to the original function if it's not your process ID. And if it's your process ID, then return nothing, because this hook code will return nothing on any process, because we don't check whether, for what process ID. So let's put in the process name. It was PSC killer 3. Yeah, and the model, it's kernel 32.ll, and the function would be open process. Now this should work. We're just gonna remove this, we don't need it anymore. Or actually we might, yeah, it's actually a good idea to have it. So we're just gonna make it look a little better. And Oh, it's already 25 minutes. Oh shit, the time goes fast. Oh, fuck that. So now it should work. So let's open up GNG. And let's open up Ollie debug. Just to see everything, if everything is done correctly. Let's define PSC color. And we attach this to PSC color. Well, that went fast. And we're gonna find the model, kernel 32, and let's run it then. So now everything should be placed, and we're just gonna check. So let's see if a code actually is written to the CodeCave. Yeah, seems like it. As you see, 32, C0, C2, 8, 0. So yeah, it's written perfectly in there. Let's see if the original function now contains a jump to CodeCave. It's on 755B9. Oh, just down here. A. Oh. Yeah. 7F. Yeah, see, it contains a jump to 77000, which is, yeah. So this should actually work now. Let's test it out. Let's open the, let's have to run. And now let's try to kill this, yeah, just this, doesn't matter. Doesn't work. As you see, can't kill it, can't kill it. Can't kill this either. Just to make some more explanation and see how this actually works. Just gonna put a breakpoint. Let's press kill process. Go to where it jumps to, so it goes to this function, which just make it return nothing. So yeah, it works. Thanks for watching, and yeah, this was just a short tutorial on doing a open process hook and not letting it get a handle. And this could very easily be detected because we don't set the win API error, and yeah, if this would return nothing, there would be an API error, which there isn't because we don't set it in a hook code. So yeah, but well, as I said, this was just a simple tutorial to show you. So have a nice day.